station in the band map.
Sorry, Rudy.
That's okay. The next station in the band map that is workable, and literally over the next second and a half, I would decide whether or not this is a station I want to work. And I would work them. If not, I'll hit, what is it, Control Q or Command Q and go back to my run frequency. So I find this extremely helpful to maintain a high run rate without being an SO2R operator. Full disclosure, I am really terrible at SO2R. And last but not least, again, hopefully many are using the clusters in a similar way. I use the spotting information coming into the information window as one of the many decisions on whether or not I should change bands. If I see that I'm not getting very frequently spotted, if the rate is slowing down, it's perhaps time to switch bands. And alternatively, when you're considering whether or not you should switch to a new band, you can go to the new band, quickly call CQ, see whether or not you're being spotted, and then decide, excuse me, whether or not you're going to stay on that band or go back to the original one. Now, granted, these are capabilities that to a large degree are made available because of the reverse beacon network. But the reality is most of us use clusters as opposed to RBN directly, because of the better filtering capabilities that clusters present. So the net is, I've been a big fan and a passionate user of clusters for many years. But at the same time, I also have been experiencing sort of consistent challenges using these clusters. The first one is around finding a cluster. I think N1MM has made it really trivial, super easy to find a cluster. But we also have to ask ourselves, why do they have this capability, the live lookup as well as the quality information? And we'll talk about this later. And the second challenge is, okay, you connect to a cluster, but at least in my experience, very often I will be staring for a long time at a blank screen. And again, I don't think I'm the only person having that challenge, because N1MM has that big button that says, why don't I see spots, right? The fact that they have taken the time to create this capability means that this is a persistent problem. So that's how I'm thinking about my personal experience using clusters, and that was really what influenced my experimentation. So let's dive a little bit deeper in these two steps. Again, thanks to the N1MM team, fantastic job. They have made it super easy to find clusters. However, the reality of the vast majority of these publicly available clusters is that they're being operated by Good Samaritans, right? These are nodes that are operated by volunteers, and they have one or many different constraints or considerations when running these nodes. Some of these nodes are CPU or bandwidth or otherwise constrained. They most of the time don't have backup power, backup internet. The computers are being used for multiple services or different purposes. And very often, these nodes are simply not available. Again, not necessarily a huge problem because there are a lot of clusters, but this simply illustrates the problem that consistency in terms of availability and accessibility of these clusters is not there. And they use different software. And we'll talk about the implications of the software in a few minutes. So again, I thought that I'm not the only one struggling with the challenge of finding, excuse me, reliable clusters, because otherwise the N1MM team would not make the time and effort to develop the quality score. So the net is, over the past maybe 10 years or so since I have started using clusters. For me, it's been a frequent experience of having to switch clusters either between contests or even in the middle of a contest. And that creates friction. And we'll talk about the friction in a second. So the friction really stems from the fact that once you switch clusters, you may or may not be seeing spots that you want to see. As I mentioned on the previous slide, one of the challenges is different clusters very often use different software, and even within the same software, they may be using different versions. So what that means in plain English is in order to fully navigate or fully take advantage of these clusters, you need to know different commands for the different cluster types. And sometimes you don't even know what software the cluster is using because they may not necessarily include it in the welcome message. This also assumes that you actually do know commands. My personal experience is I live pretty much 24/7 in technology for work. And in my personal life, I really want simplicity. I had zero desire whatsoever over the years to learn any of these commands, particularly knowing well that they're very different from cluster to cluster. So I felt that not only for myself, but also for others, this might be a friction. Hold on one second. The other thing is different clusters distribute different spots for various reasons. Again, some choose to distribute RBN spots, others choose not to. And until you connect to one, you don't know whether or not they distribute these spots. And then the, excuse me, and then the next challenge is when you do connect, by default, virtually all the clusters out there, that's how the software is configured, will only send you human-generated spots. You really have to work hard if you're connecting to a new cluster for a first time to make sure that you unleash the full stream of spots so that later you can filter in the loggers. And by the way, I'm a firm believer that the logger is really the best place to do a lot of the filtering because it is context specific, right? The logger knows whether or not you're single operator, single bed, whether or not you're multi, SO2R, and so forth and so forth, and therefore really adjusts what you see on the screen in order to be more useful and more actionable for you. So, for those of you who watch Shark Tank, usually the theme of their presentations go with, so I thought there must be a better way. And that's exactly what I thought. There must be a better way. And I started looking for ways to abstracting myself from knowing the mumbo jumbo of different cluster commands. Again, I had zero desire to learn any of these commands. So this is how I stumbled upon two utilities, both of them being free and easily available on the internet, CC User and RX Plus. CC User is developed and maintained by V7CC, the person who writes the CC cluster software and maintains one of the busiest cluster sites. And RX Plus is designed by a Swiss guy. I don't remember his call sign. The funny thing is, for a long time, I had forgotten about CC User. When I first started contesting using spots, that was many, many years ago. At the time, N1MM did not have a keep alive feature. And when operating from Canada, from V3 over a cellular internet connection, very often N1MM will lose connectivity to the cluster. So at that time, I was using CC User that always had the keep alive capability to be the buffer between the logger and the cluster and maintain that reliable connectivity. But as soon as N1MM developed the keep alive capability, I didn't really feel the need to use CC user and abandoned it. That's again when I discovered that it actually has a lot more benefits beyond just keeping the connections alive. So I will spend a few minutes talking about CC user simply because I'm far more familiar with it. If I were to venture to guess, my guess is that RX Plus is very similar. The user interface might be different, but fundamentally they do the same. So what do they do? So there are two ways, or there are two levels of telling the cluster what you want. The first one is sort of the general settings for the cluster, and I would not call them filters. I would call them settings, and they basically say this is at the highest level the type of information I would like to receive. So in this case, on the screen you see that I have set up mine that I want to see bottom of band announcements, which is the BOB checkbox. I'm interested in grids. I'm interested in 2-digit precision, and so on. And everything that is not checked is the kind of stuff that I really couldn't care less. And likewise, from mode's perspective, since I'm currently using CC cluster to monitor my own cluster, I wanted to get all the available spots that are coming, regardless of mode. So this is the basic. And again, regardless of whether or not you're connecting to a CC cluster or DXSpider or ARC cluster, whatever the case may be, there are similar capabilities. And some of these windows or some of these options may or may not be available based on the capability of the cluster. One very important, and I guess very peculiar aspect of clusters is you always have to tell the cluster, you have to push that button, tell cluster, in order to effectively make the changes permanent. If you simply click in the user interface without clicking tell cluster, these changes will not stay. In fact, they will not take effect at all. Conversely, if you don't know what your settings were for that particular cluster, you can always click on Ask Cluster, and the cluster will check the boxes that you have previously enabled. And again, going back to my previous observation that, at least in my experience, inevitably I find myself switching from cluster to cluster. It's kind of helpful to know what you have set up for that cluster previously. So that's on the general cluster settings. The next one is with respect to filters. And my God, there's a lot of filtering, and I think this explains why there's so many different commands for setting filtering. I'm not going to go through each and every permutation on filters, but I'm going to focus on the two that in my mind are the most commonly used. The first one being the band filters, right? Not everybody cares about every single band. And the second one, the DX and the spotter country/state location, so that you can be a little bit more selective what kind of data you're collecting or responding to. So the interface is very easy, but at the same time is fairly straightforward. I think the busyness comes from the fact that we in ham radio have a lot of bands. So there are a lot of boxes to be checked or unchecked. But beyond that, the rest is fairly straightforward. So as you can see, we have the ability to select different bands that we want to collect spots for. I have no idea what the legacy is and why bands have been broken into low and high type of frequencies. It is what it is, right? It's a legacy thing. But the salient point here is that as you're deciding what to accept or reject, you need to work through all the boxes here. I do want to draw your attention to the dotted oval at the lower left corner. This is where you tell the cluster whether or not you'll be, how are you going to configure it? Are you going to configure it in reject mode, or you're going to configure it in pass mode? Different people have different preferences, and the CC user utility gives you the ability to take either approach. In the middle, you can also see that you can have different filters based on time. Honestly, I've never experimented with this. I don't find it particularly useful. And you can configure other settings, such as when you first connect to the cluster, how many spots you're going to collect that you have missed, as well as establish additional filters based on keywords, call signs, and so on. Again, can't emphasize this enough. Make sure you hit that tell button, otherwise the cluster doesn't know that you have selected this or that. And similarly, the country, and I've only used country, but state is in a pretty similar format. The country information gives you the ability to be extremely precise in defining what you want to see and what you don't want to see. So all the countries in the world are divided by continent, which is towards the right of the screen, and you can have individual selections for each continent. And likewise, you can take another level deeper, which is you can define the spotter, the X country, and so on and so on. And again, you can either operate on accept or reject mode. Again, you can go really crazy and you can define this on a per band basis. Personally, I've never taken the time to go that deep, didn't really find a lot of value in that. And again, remember to tell the cluster that you need to save this. So let me pause here for a second and make sure that if somebody has any questions or want me to double click on anything in particular, I can take the time to do so.
Okay, Rudy, I do have one question. Does this program CC user always have to be running in the background, or can you set everything up? And then
yeah, you can set it up, and that's what I do, right? I set it up once. Now you can keep it in the background. There is really no downside to it, but this is pretty much set it and forget it. Which, by the way, reminds me of something that I did not include in the presentation, and I should have, because I learned about this capability recently, and I think it is a great capability. So clusters have the concept of SSIDs, just like Wi-Fi networks. And basically, SSID is your call sign, dash, and a number. Could be N2WQ-1, -15, -99. Basically, the numbers go from 1 to 99. And what's interesting is that you can actually have different settings for each SSID. There is a little disclaimer here. The first 15, 1 through 15, are actually the same. They're more used if you have multiple connections coming from multiple places to make sure that the cluster can keep track of the different connections, but they're treated the same. And then 16 through 99 are kept individually. So conceivably, you can have whatever the number is from 16 to 99, I guess 83 SSIDs, where you can have them for different contests, right? If you want to do ARRL-CW, you don't care about SSB spots. And if your logger computer struggles doing all the processing, that's a good place to remove some of the traffic coming to your computer and let the cluster do the heavy lifting. So keep that in mind. My understanding is that this is universal across all the clusters. SSIDs 16 through 99 are individual. So you have 83 different options to configure the cluster any way you choose.
Hey, Rudy, I've got a question.
Yep.
Yeah, Mark here. I don't know that it's within the CC user platform or the other, or within the basic logging program, but I'm wondering, in the telnet scenarios where you spot or not spot yourself, but you find a multiplier who happens to be outside your band. Let's, classic example, some station in Europe
Yeah.
below 7100 or 71128.
Mhm.
But your operator class, your license class doesn't allow you to operate, say, either in the extra band, because maybe you're a general, or you land or you call somebody out of band, transceive, you're calling a DX station, at 70, 90, obviously out of your band. Is there any way of incorporating or putting a window that pops up and says, hey, you're out of band, or, something like that? Is that in any of your travels, have you seen this kind of capability, or is it already there and I'm just missing it somewhere? You know what I'm saying?
Yeah, I totally understand. So I think there are two questions here. So the first one is, and you didn't really ask it, I'm implying it. The first one is a spot which is in the on the wrong frequency. I think those are easier to handle because spots are tagged with mode. So you can choose to ignore the frequency and simply filter by mode, which was the very first screen I showed. Your second question is the difficult one, which is whether or not you're actually allowed to work that spot because of your license. I honestly don't know what the answer is. You can certainly create, although I'm not sure that's the case. I wonder if you can create custom bands in the band definition so that you can say, this is where I'm allowed to operate and I don't want to see spots outside of that. And second, and full disclosure, I've never really used that feature. N1MM has the ability to define mode by frequency. And I would suggest you probably start there because I'm not sure that clusters can do that or can do it consistently across all the clusters. But I certainly will be more than happy to look into it and see whether or not clusters can handle that.
I'll just jump in with
I think the end result is looking at, say you've blindly do the control up and down arrow and you're just going through the band map, not really paying attention to the frequencies, and you call somebody or you're about to call somebody and it gives you a pop-up warning, it says, hey, you're out of band or something, as basic as that. I mean, that would be kind of nice to have that feature. I see a lot of people making mistakes.
I think you should be able to do that because I know that with DX Spider you can make a very specific filter by frequencies, so you can give it a range, and so I would think you should be able to exclude those that are outside of your privileges.
Well, I'm not looking to exclude anybody from a station being spotted. I just don't want to transmit out of band, and I need a warning.
Remember, the transmitting is done by the logger. So whether or not you can pop up such a window very much depends on the logger. Yeah. So again, my suggestion would be to look at what you can do with defining mode per frequency, as opposed to just relying on what the cluster is pushing your way, and take it from there. Again, I've never really played with this. I'm not the right person to answer that question.
Yeah, okay, got it. Thank you.
Can I ask you a question, Rudy?
Sure.
So CC user lets you configure these settings for multiple different clusters. How do you use those different clusters that you've configured? Do you use just have one primary and others are backups, or do you use them differently?
So that's a great question, which kind of bleeds into my next topic, which is I got sick and tired of switching clusters. And one of the challenges around switching clusters is not only trying to figure out how to set up these filters, but there isn't really I guess, some sort of a configuration file in any of these utilities that you can apply to each cluster. You literally have to go through the process of configuring it for each and every one of them. So I really got tired of this, and I asked myself the question, is there a better way? And in order to understand whether or not there is a better way, I went back to that screen in N1MM that shows the availability of different clusters. And once I started digging into the topic, I came to that realization that the cluster network is really operated by a large number of Good Samaritans. So everything they do is very much limited by the resources they have, as well as by their amount of free time and willingness to invest in maintaining that infrastructure up and running. The general attitude is, well, if that cluster goes down, there's so many others, go and connect to someone else, which fundamentally is a sound answer, right? We have plenty of clusters to choose from. But again, from my standpoint, personally, in my business dealings, I'm obsessed with great customer experience and removing friction. So that type of reaction really drove me absolutely crazy, because I don't think people should be switching from cluster to cluster. So this is when I decided to play a little bit on my own and figure out what I can do for my own purposes, not necessarily trying to change the world, but just take advantage of existing technology to come up with a better solution. And to be crystal clear, the solution was not to create a new cluster, but really figure out better ways of deploying existing cluster software in such a way that removes that end user friction. So the goals were fairly straightforward. First, I wanted to learn something, right? To me, that's new territory. I have zero background, or had zero background in clusters. And all that friction, all that experience piqued my curiosity. I also wanted to keep myself busy during the winter months, right? My stations are not in Connecticut. I have nothing to use here. So it's either the Caribbean or Canada, and Canada is covered with snow. So I have 4 months, 4.5, 5 months of doing nothing. So I might as well apply it to something useful. And at the same time, again, based on the friction I had identified, I had established a few technical goals for myself. The first one is make sure that the darn thing is always on. Yes, it's ham radio, yes, spots, but at the end of the day, we in the ham radio community actually depend pretty heavily on that. I wanted to make sure it's scalable. Again, what I learned is various nodes have different resource constraints. And I think in today's world, technology is dirt cheap. There is absolutely no reason to be resource constrained. At the same time, I wanted to make sure this is economical. Didn't really want to spend a lot of money on this. And, again, my personal preference was I want to see all spots on by default. The traditional thinking in clusters is we're going to show you pretty much nothing. Basically, you're going to see just CW and SSB spots generated by humans. And if you want to see anything else, you need to type a bunch of commands to open up the full stream. And here my hypothesis is that FT8 has attracted a lot of new hams that most likely have no clue how to open up the full spigot, and they will struggle. So again, it's a less than perfect user experience. And my last goal was figure out how I can do something that can be easily replicated, really one-click rinse and repeat that anybody else can do. And from the very beginning, I had decided to build all this in cloud, and cloud really gives me the ability to templatize this, requiring very little skills to make it happen. So what's my progress to date? Again, I'm still tinkering with this. I have the solution up and running. I decided to run it in the east region of Amazon for obvious reasons. I'm far more interested in providing services, first and foremost, to the YCCC community, followed by Contest Club Ontario. So running it in Ohio seemed to be the obvious choice, which is close to both clusters of users. My choice was V7CC for the very simple reason that I felt it provided the best support. I am really not interested in writing cluster software, right? So I didn't want to start tinkering with any of the legacy stuff that is no longer supported, and I would be totally on my own. Going back to the great user experience, particularly for new hams that have no experience with clusters, I actually pre-populated the entire FCC database with everybody's call sign so that by default, they see all spots, right? They can go and turn it off. That's fine. I don't want to impose anything on anyone, but at least I want to make sure when they connect to the cluster, they see spots as opposed to, if they rely on human generated spots, see one maybe every minute, 2, 5. I think that could be very discouraging. And going back to one of my goals that I mentioned before, wanted to make sure that the solution is economical. So currently I'm running half of it in one availability zone because I have not seen enough load to trigger the scalability considerations. So my current cost is $32.06. And I think it is important to highlight the 2 points I'm making, which is this is literally going to a dealer and buying at sticker price. In cloud, there is the concept of on-demand pricing, which is you just show up and say, hey, I want to run something. That's when you pay full price, and that's what I've been doing, versus different levels of commitment where it can get substantial savings. I also did quick back of the envelope calculation and calculated that a fairly low-end PC with the usual, actually not usual, the very lean 250 watt power supply running all the time is going to run a bill of roughly $27 per month, which is the fully loaded cost of both generation and distribution. That's at least here in Connecticut. That's my fully loaded cost, about 15 cents a kilowatt hour. Obviously, if you're running this in California, the price is going to be astronomical. And the last geeky aspect I would like to point here is, which was a big lesson learned for me, is running things in cloud has different computational capabilities that what we do at home on our computers. So again, for the purpose of experimentation, I picked what in cloud is considered a fairly low-end computer, which is with 2 processors. Now, granted, they're very high-end server-grade processors, but only 2 gigabytes of memory. Well, the thing has been working absolutely flawlessly. It's amazing. Again, so far, I have not seen a spike of load beyond 2%. I have not seen hundreds and thousands of users, right? Full disclosure, but at this point, I feel extremely confident that we can make this thing very highly scalable. I also learned that Windows is not created equal. So what we run at home on our computers is extremely inefficient. What the rest of the world runs in their data centers, in this particular case, Windows Server 2022 Data Center Edition, is unbelievably efficient. All the talk about Linux versus Windows with respect to efficiency, excuse me, really goes out the window when we start looking at data center grade operating systems. So that's where we have, that's where I am. Again, it's been a fascinating journey. I've learned a lot of stuff. I still feel that I have not scratched the surface with respect to scalability, haven't generated a lot of traffic. I'm actually working with V7CC to remove some of the built-in capabilities in the cluster software so that I can create thousands and tens of thousands and hundreds of thousands of connections to simulate heavy load and figure out what is the tipping point when I need to bring up different instances of the software and so forth. So happy to answer any questions.
So the feed for the AWS is the VE77 cluster, you said?
I'm sorry, what was the question, Ken?
The feed for the AWS node that you're running is actually VE7CC.
Did you say the feed? No, I'm actually using feeds from many clusters.
Okay.
My goal is to really build a highly available system, not only in terms of the underlying software and hardware, but also the feeds. So I'm currently taking feeds of approximately 27 other clusters, including RBN.
Right. Okay. Just a quick
Hey,
roll.
Rudy.
How many folks are using it? Using this at this point? I know I am.
Currently, it's 37. Again, the server can't even notice that people are using it.
And what's the host name of it?
It's cluster.n2WQ.com port 7373.
7373?
Yeah.
Okay, and that's Telnet.
Yes.
Okay, cluster.n2wq.com 7353.
I would love to break it, but again, unfortunately, so far there hasn't been enough load because I still don't know what the breaking point is.